Hello friends, welcome to this YouTube channel. Today we are going to solve one numerical problem on three-phase induction motors. By solving this problem, we shall learn how to determine overall efficiency and shaft torque of a three-phase induction motor using approximate equivalent circuit when circuit parameters are given. A 440 volt, 50 Hz, 8 pole, 3-phase star connected induction motor has following per phase parameters referred to stator side. R1 equals to R2 dash equals to 0.1 ohm, X1 equals to X2 S dash equals to 0.7 ohm, RC equals to 100 ohm, and Xm equals to 25 ohm. The mechanical losses are 1000 watts and the slip is 4%. Using approximate equivalent circuit, we have to calculate rotor speed, stator current and its power factor, developed torque, shaft torque and efficiency. Let us first write down the given data. For stator winding, resistance per phase R1 equals to 0.1 ohm and leakage reactance per phase X1 equals to 0.7 ohm. Expression for stator impedance per phase Z1 equals to R1 plus JX1 equals to 0.1 plus J times 0.7 ohm. For rotor winding, given resistance per phase referred to the stator R2 dash equals to 0.1 ohm and standstill leakage reactance per phase X2S dash equals to 0.7 ohm. For any value of slip S, rotor impedance per phase referred to the stator Z2 dash equals to R2 dash by S plus JX2S dash, given slip S equals to 4%, that is equal to 0.04 per unit. Therefore, Z2 dash equals to 0.1 by 0.04 plus J times 0.7 ohm. That gives us 2.5 plus J times 0.7 ohm. Let us now determine equivalent impedance per phase. ZEQ equals to Z1 plus Z2 dash. Using values we get 2.6 plus J times 1.4 ohm. This may be written in polar form as 2.953 ohm at an angle 28.3 degree. Given line-to-line terminal voltage VL equals to 440 volts. For star-connected induction motor, terminal voltage per phase ET equals to VL by root 3, that is equal to 440 divided by root 3, that gives us 254 volts. We have computed equivalent impedance per phase ZEQ equals to 2.953 ohm at an angle 28.3 degree. Expression for rotor current per phase referred to stator side I2 dash equals to ET divided by ZEQ. Taking terminal voltage per phase ET as reference, we get I2 dash equals to 254 at an angle 0 degree divided by 2.953 at an angle 28.3 degree. That gives us 86 ampere at an angle minus 28.3 degree. Now we shall determine equivalent load resistance referred to stator side. RL dash equals to 1 upon S minus 1 into R2 dash. Given per phase rotor resistance referred to the stator R2 dash equals to 0.1 ohm and slip S equals to 0.04 per unit. Therefore, RL dash equals to 1 upon 0.04 minus 1 into 0.1, that is equal to 2.4 ohm. For three-phase induction motor, total mechanical power developed PM equals to 3 times I2 dash square into RL dash. Using values we get 3 into 86 square into 2.4, which is approximately equal to 53,251 watts. Now we shall determine total shaft power output. PO equals to PM minus PR. Given mechanical losses, PR equals to 1000 watts. Therefore, PO equals to 53,251 minus 1000. That gives us 52,251 watts. Let us now determine working component of no load current per phase. IW equals to ET divided by RC. Given per phase resistance representing core losses, RC equals to 100 ohm. Therefore, IW equals to 254 divided by 100, that gives us 2.54 ampere. Now we shall calculate magnetizing component of no load current per phase. Im equals to Et divided by Xm. Given per phase magnetizing reactance, Xm equals to 25 ohm. Therefore, Im equals to 254 divided by 25. That gives us 10.16 ampere. Expression for no load current per phase. I0 equals to IW minus J times Im, that is equal to 2.54 minus J times 10.16 ampere. Now we shall determine stator current per phase. I1 equals to I0 plus I2 dash. We have determined rotor current per phase referred to stator side. I2 dash equals to 86 ampere at an angle minus 28.3 degree. This may be written in Cartesian form as 75.721 minus J times 40.7716 ampere. Using values we get I1 equals to 78.261 minus J times 50.9316 ampere. This may be written in polar form as 93.3746 ampere at an angle minus 33 degree. In polar form, we can write stator current per phase I1 equals to I1 at an angle minus phi 1 equals to 93.3746 ampere at an angle minus 33 degree. For star connected induction motor, stator current per phase equals to stator line current. Let us now determine stator power factor. Cos phi 1 equals to cos of 33 degree, that is equal to 0.83867 lagging. For three-phase induction motor, total input power Pin equals to root 3 times VL into I1 cos phi 1. Using values we get root 3 into 440 into 93.3746 into 0.83867, which is approximately equal to 59,680.6 watt. Now we shall calculate overall efficiency of the motor. eta equals to PO divided by Pin. We have obtained total shaft power output PO equals to 52,251 watts. Therefore, eta equals to 52,251 divided by 59,680.6. That gives us 0.8755 per unit or 87.55%. Given number of poles of the machine P equals to 8 and supply frequency F equals to 50 Hz. Let us now calculate synchronous speed. Ns equals to 120 F by P. Using values we get 120 into 50 divided by 8, that is equal to 750 revolutions per minute. Now we shall determine rotor speed. Nr equals to 1 minus S times Ns. Given slip S equals to 0.04 per unit. Therefore, Nr equals to 1 minus 0.04 into 750, that is equal to 720 revolutions per minute. Expression for developed torque Td equals to Pm divided by 2 pi into Nr by 6T. We have determined mechanical power developed Pm equals to 53,251 watts. Therefore, Td equals to 53,251 divided by 2 pi into 720 by 6T, which is approximately equal to 706 Newton meter. Expression for shaft torque TSH equals to PO divided by 2 pi into Nr by 6T. We have obtained shaft power output PO equals to 52,251 watts. Therefore, TSH equals to 52,251 divided by 2 pi into 720 by 6T, which is approximately equal to 693 Newton meters. So today we have solved one numerical problem on three-phase induction motors. By solving this problem, we have learned how to determine overall efficiency and shaft torque of a three-phase induction motor using its approximate equivalent circuit when circuit parameters are given. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.